So like I said, we're going to go ahead and do our Exam 1 review for Stat 200, or 100. And we are going to just basically go through everything that we've learned up to this point, do a little bit of a review, and then we'll have some practice problems at the end. Feel free to ask me any questions at any point. And yeah, so let's start by talking about basically the different types of variables that we talked about. So we know that we have our explanatory variables and our response variables. So remember, our explanatory variables are going to be the ones that are explaining the difference. So they're explanatory, let's explain the difference in your response variable. So your response variable is what you get. So basically, your explanatory variable is explaining that. It's saying, you know, how did this response variable come to be? Like, what is that difference? Our explanatory variable is independent because it's predicting. So if something's predicting something else, it has to be independent of the others in order for it to be valid. And then also, on the other hand, our response variable is dependent, and specifically, it's dependent on the explanatory variable. So yeah, and then remember, compounding variables are another type of variable that we want to watch out for. It's just going to be a variable related to the other variables in the study, but it's not something that we're actually looking for. So it can skew our results and make them unrepresentative, so that's important to look at. And then keeping in mind that if we don't want to have confounding variables, or if we want to control for them, we would do a randomized experiment, which is where the term treatment comes into play, because if we do a randomized experiment, that means that there's going to be some sort of treatment. So yeah, and remember, treatment is going to be if we put some type of manipulation on our participants, and that would be something that you do in an experiment. Okay, so more about variables. These are other ways to categorize them. So we do have categorical and quantitative. So remember, categorical are just going to be labels. Nominal and ordinal are two different types of categorical. Our nominal ones are basically going to have any type of hierarchy to them, and they can have any order. These flavors, car brands, any type of brand, really, just a different category. Those are nominal. And then ordinal means that they have to have some sort of order to them. So that can be anything from class standings, or like elementary school, middle school, high school. Those are ordinal categorical variables because they have some sort of order in them. And then quantitative are going to be our numbers with consistent intervals. So we have discrete, which are going to be quantitative variables that are, so they have a value attached to them, but they can only take on a set number of values. When in comparison to continuous, it can basically take on any number on that number line. That's the main difference there. So discrete can be things like people or cars, houses. Continuous are more measurements like weight, height, any type of measurement like that. So that's the difference there. Okay, so when we're talking about sampling, there are a few issues that we want to watch out for. So we want to keep in mind that if, so low response rate literally just means what it says, that there was a low response rate, so the sample that you got may not be representative because not a lot of people responded. And then non-response bias is going to be obviously like if they don't, like if whoever you're looking for, like you take a sample and then people don't respond, that'll be non-response bias. Basically, there's no, they're not able to, they can't really tell you about the people if they don't respond. And then question wording issues, so that's basically all the different issues when you're writing a research question. So we talked about this, I think, in Unit 2, lesson 2 or 3, when we talk about writing research questions. We want to make sure that our questions are worded correctly. We don't want to have bias or filtering or anchoring and that kind of thing. We can make sure you go ahead and review those and understand those. And that's basically just talking about that you write the question in a certain way that may favor or not favor a certain response. So that can create an issue with sampling there. Okay, so when we have all these variables, we can use them to do a study. So there's two different types of studies we can do. So we can have experimental or observational. So remember, like I said before, if you're doing an experiment, you're going to impose some sort of treatment onto your participants, and then manipulation treatment, same thing. So you're actually impacting what the participants are doing or how they're acting. And then observational is the opposite in the fact that you're just watching your participants. You're not manipulating them. You're not doing anything to them to change it. So that's the main difference there. Naturally occurring state of events. I always liken this to people watching. If you sit on your front porch and watch people go by, and you are observing them and taking data about them, that'd be observational because you're not putting any type of manipulation onto that group there. Okay, so reliability, it's synonymous with consistency. So basically it's saying like how consistent is the data that we're getting. So if something's reliable, it means that if we took that test over and over and over again, we would get similar or the same scores. If you have a small sample size, you are going to have low reliability, so low consistency. So this just reiterates the point that we always want to have a large sample size because then we can have higher reliability and higher consistency. Low sample sizes, small sample sizes are going to be the ones that there's more chance for bias or obviously, low reliability in this case. And so yeah, if you're using a certain kind of instrument for a test and the results on the subjects you're testing are the same for the first and the second and third try, whatever, that's when you would consider it reliable, and that wouldn't happen if you had a small sample size. Okay, so then our margin of error is basically this is kind of like talking about consistency and the fact that we're talking about, how much error is going on here, how much wiggle room do we have kind of. So this 1 over square root of n, that's the equation to find your margin of error. And because it's set up like that, and just in general, it does have an inverse relationship with sample size. So if you were to increase your margin of error, your sample size would be smaller. It's kind of more so, if you make a small sample size, you're going to have a high margin of error. So once again, you want a large sample size to decrease that error and increase your consistency in that case. Okay, so probability sampling methods. So I just want to go over, we talked about all of these here, but I just want to go over so simple random sampling, that's literally just when you're taking random samples from the population. That's like our basis sampling method. Stratified and clustered are definitely the ones that sometimes are a little tough to understand. So when we're talking about stratified sampling, it's where breaking up our population into groups based on a certain factor that could influence the variable that we're measuring. So something that we think might cause a problem, maybe it's the proportion of this, like a certain group in that variable, and then or let's say all of the groups have unequal population sizes, and you want to make sure that it technically is equal, so you want to take the same percent from each of them to make your sample, because then it wouldn't really make sense if you were to take 10 from each, because maybe one of the samples is only 10. So if it's only 10, then you're taking that entire group, when in case of another one, then maybe it's 100, you're only taking 10% of it. So by taking the same percent of each, that would be stratified sampling there. It's still going to be random, but then after you divide this population into homogeneous strata, so they're all going to be the same, and then you can take a simple random sample from each and combine them, and that'll be your sample in the end. And that's different from cluster sampling, because for cluster sampling, you still divide it into groups, but the groups are going to be different from one another. So in that case, you won't have to take another simple random sample from all of them like you would do in the strata. In this case, you have all your clusters, and then instead of taking another sample out of them, you would just use all of your clusters as your actual sampling unit. So yeah, the main difference between the two, analysis is done within each strata for stratified sampling, and then for cluster, it's done with the entire cluster for the sampling unit. So there's kind of one more step for stratified sampling if you think about it that way. Systematic sampling is just taking every first, second, third, person on a list of your sample. It's creating a rule and then taking every person who fits that rule. And then multi-stage is just a combination of the different probability sampling methods that we just talked about. Okay, so non-probability sampling, this is going to be when we're discussing the fact that like our sampling, there's not like a probability for one or the other. There's not a certain probability that one could have happened over the other. So these are more like similar to like observational studies. So volunteer samples are, the sample chooses itself in the way that, if the person volunteers to participate, they do. If they don't, they don't. So the sample is just based upon who volunteers. And convenience samples, their sample doesn't really choose itself. The person looking for the samples does, but they only pick what's easiest. So that's just taking whatever's most convenient to you. If you're trying to find out about all Penn State students, but you just take a sample of your English class because that's the most convenient thing you could do, that would be convenient sampling there. And yeah, so they're similar to observational studies. Like I said, we do have a high chance of bias because we're not controlling for anything. And, there's obviously room for human error here. And so, yeah, the main thing with these are they're just not as representative as if we were going to an experimental study here. All right, so we'll just go over briefly the different measurement data displays. So just keep in mind, when we use these. So when I say measurement, we're talking about ones that we use with quantitative data. So we can use a histogram or a dot plot. Both of them are just showing our basically the frequency of each value on the x-axis, how many times it occurs, and then you're able to compare them to one another. Histograms they both basically show the same thing in the same shape. They both show shape, but then histograms you can use for large amounts of data because you can basically fit whatever you want inside of those boxes, while in dot plots, each different sample is representative in each individual observation is represented in a dot. So it's better for smaller samples because you can't put a million dots in a line there. It's just not logical. Okay, so if we're talking about shape, this is something that we talk about when we're when we're talking about measurement variables. And in this case, if we're talking, I'll just show you examples. So if we're talking about mean, median, mode, so symmetrical, that'd be if we had a distribution looking like this. So that's going to be symmetrical. So that means that basically all of these are the same. So this is our mean, this is also our median, and this is also our mode. So it's the most commonly occurring one, it's the average, and then it's the middle one too. So that's why they're all the same. And then left skew would be looking like this. Our mean is less than our median, which is less than our mode. And then right skew would look like this. And then our mode is the smallest, mean is the largest. So those are just different ways that we talk about measurement data and when we describe the shape of them and the distribution. Okay, so here's a few other measurement data displays. So we do have a box plot, and the same side-by-side box plots are just two box plots beside each other. These are good for just talking about our data as a whole and then able to look at like the different percentages of it, because a box plot's always split up into 4 different parts. And we have our middle 50%. We always have our median in the center there. And then for side-by-side box plots, it's good for comparing 2 different groups because you can easily see, in comparison between, the maximum of each of them, and you can see, which one's higher, which one's lower. Compare the medians here depending on where the lines are on the graph. So that's the main situation there. So these, once again, are used with quantitative variables. And yeah, so the 5-number summary is something we use often. It's very easily seen on a box plot. So if we were to draw this out, if I were to draw just a random box plot and draw the 5-number summary, we'd have our minimum and our maximum. And then we'd get our Q1, our Q2, and our Q3. So Q1 is going to be the 25th percentile, Q2 is going to be the 50th, and then Q3 is going to be our 75th percentile. So remember, percentiles talk about the percent of the data that lies at or below this value. So, and then this is going to be our middle 50% of the data. our interquartile range here. So that's basically the 5-number summary just represented, on a box plot here. And then, like I said, the interquartile range is going to be the range between Q1 and Q3, so from here to here. And that's going to be the difference between the first and third quartiles, giving you the center, 50% of the data there. So that's why box plots are useful, because they really visually represent this pretty well. Alrighty. Okay, so for standard scores, when we're talking about these, this is basically taking all the different numbers that we got and then standardizing them to a common distribution where our mean is 0 and our standard deviation is 1. So yeah, like this shows where your observation stands in relation to others. So maybe you have, for example, if I had 2 different graphs here, and let's say that this is going to be my z curve. Basically, let's say that our mean was 100 and our standard deviation, if a mean is 100 and then our standard deviation was 50, that means that if I were to go to 150 here, that this would also, so if we standardize this and to make 100 into 0, then our 150 is going to end up being 1, because that's 1 standard deviation away. It's 50 units, 1 standard deviation, and then this is 1. So it's just standardizing these scores into this normal z curve, so you're able to compare them to one another. Okay, and the empirical rule, basically it's a similar idea where we talk about what percentage of the data is within the different parts of the graph. So we have plus or minus 1 standard deviation is 68% of the data, plus or minus 2, 95, and then plus or minus 3 is 99.7. So these are basically just showing you that no matter what graph you're looking at, if you're within plus or minus 1 standard deviation, no matter what that is, you are going to be showing 68% of the data below that curve there. So yeah, this is just something to keep in mind when we're talking about the different ways that we can describe our data and how we can look at it in terms of a normal curve and different standard deviations there. Okay, so for case control studies, we're going to have retrospective and prospective. They're basically they're both studies that are looking in different directions in this case. So retrospective, it means that you're comparing the people that you have now with people like that you're looking at now with those who what happened before. So you're looking in the past. So for example, you can, if you're looking at a disease, you can compare, patients who have the disease now and then ask them about, past exposures for those who don't have it. And then prospective is looking forward. So it's looking at people with different behaviors and exposure, and then you follow them over time. So retrospective, you're taking people now and then looking back in the past and just making a decision. And then for prospective, you're actually looking at people and then you're continuing to watch them as we go on. So that's the main difference. Okay, let's do some review questions. So I'll go ahead and read through these, and then you guys can go ahead and check them out and see what you think, and then we'll go over them. So our first one says, suppose that there are 2 methods to the test to the amount of milk, fat, and 2% milk. Results of 5 trials for each method on the same milk shipment are shown below. So we have method 1 and 2. So go ahead and look at these and decide that when examining the results found above, which method is most reliable. So go ahead and try to answer this, and then we will go over it together. All right, great job, guys. Absolutely. So method 1 is going to be our more reliable one, and you're absolutely correct because remember that reliability is basically the same thing as consistency. And then, so in this case, method 1 is more consistent because, as you can see, all these numbers are the same. They don't have to be the same, but in comparison to method 2, it's much more consistent in this case. So method 1 would be most reliable. So good job. All right, let's do another one. Okay, a poll of 1,000 respondents is taken from Tennessee with a population of 6.5 million to determine the percentage of adults in that state who walked at least a full mile in the previous week. A second poll of 2,000 respondents is taken in Illinois, population of 13 million, to determine the percentage of adults in that state who had walked at least a mile in the previous week. Since the sample size and the population size were both twice as big in the Illinois poll, we would expect what? So go ahead and check out these answers and let me know what you think. All right, great job. Yeah, so what we want to remember here is that our margin of error has an inverse relationship with sample size. So as our sample size increases, our margin of error is going to decrease. So in this case, if we're looking, we have our Tennessee respondents, there was 6.5 million, and then Illinois had 13 million. So in this case, Illinois had a larger population. So that means that our answer would be A, because on the Tennessee poll has a smaller population, so they're going to have a larger margin of error, because remember, Tennessee poll had a smaller sample size, so that's going to lead us to a larger margin of error in this case. So yeah, it's understandable to think that it might be the same, but in this case, even though they're both very large in comparison to one another, Tennessee is much smaller. So if we're looking at it just in general, like in comparison to one another, that is where this comes from. So does that make sense why our answer is A? All right, cool. Okay. Do a few more here. All right, suppose that in a 5-number summary you find that a larger gap exists between the third quartile and the highest value than between the lowest value and the first quartile. What does this most likely say about the shape of the distribution of the data? So go ahead and check this one out. All right, great job. You guys are absolutely correct. So this would be skewed right, because remember, when something's skewed right, it means that the data to the right is more spread out than in the lower value. So if we were to draw this like on a box plot, it would look something more like this, because if we have our Q1 here and our Q3 here, we have, it says that the larger gap exists between the third quartile and the highest value. So here is our larger gap. So we have it more spread out on the right side. And this would also, represent a distribution looking like this. So as you can see, our data is more spread out here. So it would be skewed right. So good job. All right. All right, next. All right, suppose you look at two box plots comparing the weights of male cats versus female cats, and you find that the box for the males is much wider than the box for the females. So what does this mean about the data sets? So go ahead, if it helps you to draw a picture of this with the box plots, you might want to try that, but read over these answers and let me know what you think. Good, perfect, good job. So this is B, because if we think about it here, so remember our box in the middle is representing our interquartile range. So so that's the width of the box plot. So that's also representing the variability of the data. It's showing that spread there. So since the weights of female cats, or the box for males is much wider, that means that they have more variability, because how wide it is represents the variability in that case. So B would be our answer, because since the box was wider for males, it does have more variability than females. So good job. All right. Oops. All right. A Penn State poll wants to determine what % of all PSU students favor a change in the university policy about parking on campus. A random sample of 1,000 students was obtained from a list of all students who live on campus. So what is the major problem with this survey? So what do you think about this one? Absolutely, great job. So our answer would be A here, because they did use that wrong sampling frame. Because if you think about it, they excluded all the students who lived off campus, the ones who commute, like that's great, yep, the ones who commute to class, and those are important, obviously they're Penn State students, and just because they don't live on campus doesn't mean, that they shouldn't be included in the poll. So yeah, that's a major issue with this survey, because they did use the wrong sampling frame in this case. It wasn't a convenient, I see that is a good, C is a good guess for sure, because, it does kind of look like it was a convenient sample because they just took the people who lived on campus, but we don't really know if it was like convenient for them to do that or not. And they did take 1,000 students, so it doesn't really seem like that would be a convenient sample there. So the main issue is A. C is definitely still a good answer, but we would need more information. We would probably want to hear like the the researcher was unable to move off campus, to get this other information in this case. But so A would be the good one. Yeah. Does that make sense to everyone? All right, cool. Of course. Of course. All right. I think we have 2 more or something. Okay. All right, this one says, so we have a researcher wants to estimate the proportion of Penn State students living in a dorm who voted in the presidential election. He randomly picks 10 students from each one of the 65 dorms on the campus for a total sample size of n equals 650. So what type of sample did they take here? Okay, good job, guys. So let's look into this one. So remember, in this case, we had they're looking at proportion of Penn State students living in a dorm who voted. So they took all the 65 dorms. So this is going to be our entire population in this case. So this will be all 65 dorms. And then from each dorm, they took a random sample of 10. So this is going to be 10, 10, 10, and then this should, be 65 times, okay, from each dorm. So these are going to be random samples. Can't speak. Samples. And then total, they took all of these then, include all samples of 10, all 65 of them, and that made their sample size 650. So each of these samples is representing a strata. So remember, since these are already randomized, they can use, and because they selected 10 from each dorm, so since they're already randomly selected, we can use all of them as our final sample size. So this is going to end up being stratified because each individual random sample that they took, each of those each of those samples of 10 are already random, so they can go ahead and use all of those, add them all together for a sample size of 650 for our ending sample. So they basically broke up all the people in the 65 dorms into different strata of 10 random people from each dorm. So this is a strata, and then this is a strata, so on and so forth. And then they took all of the strata together to create your end sample size. So that's why it would be stratified. Does that make sense to everyone? This is definitely a tough concept. So yeah, for sure. So in a cluster sample, remember, Basically what we're looking for there is when you're going to first divide them into heterogeneous clusters. Okay, so basically you're taking each different cluster is going to be, everyone's going to be different in there. So in this case, like all of the people in the sample were from one dorm. Okay, so like the 10 people that were sampled from each were 10 people from one dorm. So they're homogeneous because they're all from the same dorm. But in this case, if it was cluster sampling, you're going to divide it into groups, but they're going to already be heterogeneous, so you wouldn't have to take these random samples. In this case, you would just take them all, like the groups would already be different from one another. So then you would take a simple random sample from all of them together. So I could just basically take a random sample from all 65 dorms and break that into clusters instead of going through and taking 10 random from each different dorm and then taking all of those 10 times 65 together and create them. Because the main difference between this case is that when we have stratified, we are making analysis within each strata because we're taking these random samples. But then for a cluster, we would take it as the entire cluster unit. So taking different clusters that are already different from one another. We're not taking random samples, they're already different. So then you're gonna use the entire cluster as a sampling unit in that case, instead of individualizing them into different strata. Does that make sense? Maybe. I know it's definitely a tough. It's something tough to wrap your head around. This I still kind of have to read over it too. But so let me. Endless extent stage from each of the 65 dorms. I was trying to change it. I know I did. There's another. If you go to my review for this lesson, which I'm not sure which one it is, but we have other reviews on this type of thing. So you might want to go check those out. Because it's all about repetition until you understand it. Because like I said, I still have to read over it. So it's all about the wording. And but yeah, so remember, so each dorm is our strata. And then we're taking this sample size of 10 from each strata. So that's why it's stratified. In the case of the cluster, we wouldn't have to do these random samples of 10. We wouldn't have to take these random samples from each because it would already be heterogeneous. We wouldn't have to make it heterogeneous by taking the random samples. So you would just use your cluster. But yeah, so I would say if it's still a little confusing, go back to that other PowerPoint. That'll probably explain it a little more in depth, okay? Okay, cool. All right, let's see. Okay, so which of the following is a research strategy that involves researcher manipulating the participant's environment in some way? Okay, great. Yeah, so our answer is B here. Case control study is basically another way of just saying that we didn't really talk about it too much. So that's one of the that's one way to know if it's not the answer because we really didn't talk about it. But that's just saying, like, if you remember when we talked about like controlling for confounding variables, it's kind of like by having like a control group that's like not having any manipulation on it, so you'd be able to compare it to that. Same thing with placebos. Same idea, a group that doesn't get any manipulation. So it's still a research study because one of the groups gets manipulation, but the other one's like controlled. So that's basically where that comes from. But our answer, of course, yeah. So our answer is B in this case because in this case the researcher is manipulating something. So it has to be an experiment, observational. We don't manipulate anything, and same with the sample survey. There's no manipulation. You're just taking that, whatever survey you got there. So, alrighty, one more. So suppose you want to know if men or women generally buy more shoes. Ask participants to keep a record of how many shoes they actually buy over the next 4 months. So what type of study are they using in this case? Absolutely. Good job, guys. So this is going to be a prospective study because they are taking a group and then they're following them over a period of time, so over the next 4 months. So this prospective study is in the future. Remember, retrospective would be in the past. So in this case, they're definitely looking into the future. They're following one group over the next 4 months, so it will be prospective. So good job. Alrighty. So that is all we got for today. Can you ever both? Well, no, that's actually a good question. You can't have both at once unless you have like you're looking at 2 different groups at the same time. But you can't ever, like you would have to have 2 different groups that you're looking at. So you would have to have a group that you're analyzing and then looking back at it, or you're having a group that you're following. So you can't do both at the same time. That's a good question. So it's usually one or the other in that case. You're welcome, of course. So yeah, so obviously, like I said, you can go ahead and watch back this video and the rest of them on YouTube. And we'll have our next review. I'm starting to review the new chapters on next Thursday. It's already October. Can't believe it. So if you haven't given me your email into the chat box, go ahead and type that in for me. If you have any other questions, let me know. And if not, you are good for tonight.